Hello students, welcome to the channel Physics by Dr. Pradnya, and today we are going to see what are the intrinsic properties of the nucleons. Now we know that this atom is made up of nucleus at the center and electrons are revolving around it. Okay, so the protons and neutrons are present inside the nucleus and they are collectively called as the nucleons. So today we are going to see what are the intrinsic properties of these nucleons. Like what is the charge, what is the mass, what is the spin, and what is the magnetic moment of the proton and the neutron. Now see here, we know that this proton has a positive charge and whereas the neutron is a neutral. So this is how we know broadly. Okay, but when we go to the nuclear and particle physics, we come to know that this proton is also made up of fractional charges and this neutron is also made up of some fractional charges, and these fractional charges are called as a quarks. So let me write that word quarks. So these protons and the neutrons are made up of quarks. So the basically there are two types of the quarks, up quark and a down quark. We also have a charm quark, top quark, bottom quark and strange quark, but these are just heavier versions of the up quark and down quark. As we go along our syllabus, you will also come to know in detail about these quarks. Okay, so right now you just remember that there are two types of quarks are there, up quark and down quark. So let me write it here. So this is up and down quark. So this up quark has a charge of plus 2/3 electronic charge and this down quark has minus 1/3 electronic charge. Okay. Now our proton, we know that proton is a positively charged. So the fractional charges which are present on the proton are collectively, so this proton is made up of up and down quark. Now we know that this up quark has 2/3 electronic charge plus 2/3 electronic charge minus 1/3. So this collectively plus 2/3 plus 2/3 and minus 1/3, that collectively comes to be as a plus 1 charge. Similarly, this neutron is made up of down and up quark. So we know that this down quark has a minus 1/3 electronic charge. So this is minus 1/3 and plus 2/3 is equal to 0. Now the thing we want to see here is, even we are saying that neutron is a neutral, it is a chargeless particle, we can say that there are fractional charges present inside the neutron, but the total collectively charge of the neutron is 0. So we can say that neutron is a neutral. Okay, so now we know that this proton and the neutron, they are made up of fractional charges, in which proton is made up of up and down quark, whereas neutron is made up of down and up quark. Okay, so let us move, or let us see what is the mass. Generally the masses are taken in a atomic mass unit, so which is AMU. So this generally the mass of the proton and the mass of the neutron, they are nearly equal to 1 AMU, and if you generally for all calculations in nuclear and particle physics, we take the mass of the proton and the neutron as 1 AMU, but in a fraction, when you consider it as a fractional charges, so it is nearly 1.0073 AMU, and the mass of the neutron is nearly 1.0087 AMU. Generally we take it as a 1 AMU. So let me write it here in unit. So this is AMU. Now see here. Yes, let me write the mass of the electron also. So the mass of the electron is 0.00555 in AMU. We know that 1 AMU is equal to 12 into 1/12 into mass of the carbon, okay, or 12 upon Avogadro's number. Okay, so you know that what is mean by this AMU. So comparatively, see here you can see that this electron is very light particle as compared to this protons. Okay. Now, just like an electron, the protons and neutrons are also the spin half particles. Okay. So, therefore, they are fermions, or they follow the Fermi-Dirac statistics. Okay. Therefore, in a nucleus also, these nucleons are arranged in a different energy shells. They are not like the protons and neutrons are filled in a bag. Okay. So this is not the picture of the nucleus. I have made a video, separate video on a nuclear shell model. You can go and check how these protons and neutrons are filled inside the nucleus in a different energy shells. Okay, so this is because they are the spin half particles, they are fermions, and they follow Fermi-Dirac statistics. Okay, so in some next video I will explain in detail about the how the spin of this proton and neutron works. Okay, so but right now when we are speaking about the intrinsic, that is the general properties of the nucleus, we can say that the protons and neutrons are the spin half of particles. I know that. So whenever there is a charge in a motion, okay, the electric field is generated, and along with the that electric field, magnetic field is generated in perpendicular to that, and the strength of that magnetic field, it is called as a magnetic moment. For example, electron, it is having two motions, orbital motion as well as the spin motion. So whenever the charge is moving along the orbit, the magnetic field is generated along that electric field, and the strength of that magnetic field is called as orbital magnetic moment. Similarly, when electron is spinning about itself, then the magnetic moment generated due to the spinning motion of the electron, it is called as a spin magnetic moment. Similarly, whenever we consider of the nucleus, so nucleus is also not at a steady state, it is continuous in a vibrational motion as well as in a rotational motion. Okay, in my previous video I have made a separate video on the collective shell model, means how the which are the probable states of the rotation, which are the probable states of the vibration, and due to the motion of these charges, what happens, the nucleus is also having some magnetic moment. Okay, so the magnetic moment of the proton and the magnetic moment of the neutron. Now we know that when we are studying the nuclear physics, so the neutron is a neutral, but it is having the fractional charges. So whenever there is a motion of these fractional charges, magnetic field is oriented for the neutron also. So let me write it here, the formula of this magnetic moment of this proton. So you can see here, now I have written the formula for the magnetic moment of the proton, which is created due to the rotational and the vibrational mode of the nucleus, and this proton is present inside the nucleus, so there must be the motion of this fractional charges on the proton. So the whatever magnetic field is generated due to the motion of the charges, fractional charges, so that is given by 2.7973 into mu n, or and the magnetic moment for the neutron is 1.913 mu n, and this mu n is nothing but, so this is EH upon 4 pi mass of the proton. Okay, so see here, so today we have seen what are the intrinsic properties of the nucleons. So the nucleons are nothing but the protons and the neutrons. They are collectively called as nucleons. Generally we take the mass of the proton and the neutron as a nearly 1 AMU, which is much heavier than this electron. The charge on the proton and the neutron, the proton and neutron are made up of fractional charges. Okay, so proton is made up of up and down quark, whereas the neutron is made up of down and up quark. These are the spin half particles, therefore they follow the Fermi-Dirac statistics, and they have some magnetic moment due to the motion of the fractional charges. They show some magnetic moment. So this is the formula for the magnetic moment. Thank you for watching. Thank you for watching. So, in my next video we are going to speak about the nuclear forces. Thank you for watching.